Okay, good evening, everyone. Let me see here. I think we're going live. All right. Dr. Randall Gates, board certified chiropractic neurologist, also chiropractic physician at Gates Brain Health. Tonight I'm talking about how to research like a professional. And for those of you joining on Facebook, again, Dr. Randall Gates, board certified chiropractic neurologist, also chiropractic physician at Gates Brain Health. Okay, talking about how to research like a professional. Okay, let me get into the nitty-gritty of this. And here is our PowerPoint presentation. Okay, so this is a topic I feel is important because there are so many issues that are current that many people are trying to look into, individuals are trying to understand, and in doing so, a lot of people feel that it's a daunting task to really dig into some of these questions themselves with a lot of confidence. Now, many of you are researching on Google and you're looking for answers. You may be reading in Facebook support groups. You may be reading on different chat rooms and forums. And all of that is really positive. But someone may come at you with the statement, well, there is no science behind going gluten-free and Hashimoto's or something like that. I'm not saying that's true, but that's just an example. And hello to everyone who's joining. So if you're hit with, oh, that's funny. And some of you research a lot. And so if you're hit with one of those questions, you may say to yourself, well, how do I really know? How do I really dig into some of this? And I'm just going to show you tonight what I do. I'm not going to go through all the nuances because navigating Pubmed, there's a variety of different functions that you can use. And I don't think that all of those may serve you, but some of the basics may help you. So I'm going to show you that, and hopefully that's helpful. And thank you all for the well wishes. I really appreciate it. Okay. So again, as I mentioned, this is a method I found to be helpful. You can look to other sources. You can send me questions. The one thing I recommend is considering the totality of the data. So just because you find a research article saying quercetin helps traumatic brain injury, there might be other research articles saying the contrary. Also, I would then maybe talk to somebody who uses quercetin on a regular basis in their practice and say, hey, have you seen those benefits? Because I will say, in my, I guess it's now 11 years in practice, I've tried a variety of things that seem to have research behind them saying that they're going to be effective, but when I try them, applying them kind of in a clinical, well, I won't say clinical trial format, but when I try them with my patients, I may not see the effects I see with another compound. And so again, try to consider the totality of the data. Just like if you were going to go to pharmacy school, I would probably say, hey, why don't you go talk to 20 pharmacists and ask them, is this a career they would recommend that you do? So just get as much information as you can. Little tangents. And also realize that understandings are evolving. So just because we think of something now, we may have a different concept 2 years from now. Concussion is a great example of that. Rewinding 10 years ago, there was very little information on traumatic brain injury, mild traumatic brain injury rather, and any long-term effects that were definitive or ways to objectively validate that someone had a traumatic brain injury. 10 years later, we have copious methods of doing so, and we have better ways and less better ways of doing that. And in 2 years, we're going to have even better ways, so to speak. So now in going to PubMed, I'm actually probably going to go out of this screen and do a little example. So for those of you watching on YouTube, you'll be able to see how I kind of do this. I go to PubMed, I go to advanced, and then once I go to advanced, I enter in different search terms, which I'm trying to look at. And I'll give you an example of that. I also am cognizant of looking at best matched articles versus the most recent. That can be important. Looking at free full text articles may be something of benefit to you if you don't have access to a college library. And then also keep in mind, do you want to look at randomized controlled clinical trials? Do you want to look at meta-analyses? And also you can put into your search query publication date. Okay, so this is where I'm going to exit out, and I think you still should be able to see. Yes, you should. All right, so here I'm going to go back, and let me see here. I'm going to go back. Hang with me. Okay, let's just go advanced there. So you've gone to pubmed.com. It's not going to look quite like this. Let's see if we go to pubmed.com. Oh, and that didn't work. Okay, shoot. Okay. Hang with me, everyone. Okay, so PubMed. Go there. Okay, so here you can see that I can click Advanced. And when I click on Advanced, then I can say concussion. I can say diffusion, tensor imaging, and then how about I search for that? So I'm searching for the terms concussion and diffusion tensor imaging. What's diffusion tensor imaging? That's the type of imaging that shows the white matter tracking of the brain. And here you can see I have a lot of search results that show up. And some of them are free articles, so you can go in and look at them. You can also select over here for full text articles, free full text articles. You can also say, okay, I want a meta-analysis looking at diffusion tensor imaging of concussion patients. Now, a meta-analysis is where they look at a whole group of research articles on one topic. So they're going to scour the PubMed database, so to speak, for everything that's been published on diffusion tensor imaging and concussion. And then they're going to take all those studies and they're probably going to chop out a lot of them because they may not meet their criteria for what is a valid study, according to their criteria, whatever that is. And then from there, they'll say, okay, well, we have 11 studies that met our criteria, and we statistically look at all this data, and then we say, okay, diffusion tensor imaging is or is not a viable method for determining if someone has had a brain injury or not as an objective marker, as an example. So that's a nice way to do it. You can go to display options here, and you can look at most recent, or you can look at the best match. And so I've already narrowed down the search a lot, but if we took away, for example, the meta-analysis, we have 174 results, and the display options, best match versus most recent, will be a little different. And so if you really want the newest of the newest stuff, then you can go with most recent. And let me look at a question here. And then are you able to see how many people cite a particular article? Oftentimes, yes, you will be able to see that in your searches, particularly if you click on the article. You'll be able to see down here similar articles or other articles that have been cited by that article. Also by Google, you can, just by doing a simple Google search, you'll see, you know, this topic, this article has been cited by 174 different sources. So that's also a really good point. Now, going back here to our broadcast, presenting from beginning. Let me take a drink. Another thing that's important to look at is, what are the interests of the authors in publishing a piece of work? And so here, for example, this is an article on a systematic review of potential long-term effects of sports-related concussion. This was a pretty big article. I'm trying to remember who it was out of, I believe, the British Journal of Sports Medicine in 2017. You can see here this gentleman, Julian Bales. He was in the movie Concussion, or his persona was characterized in that movie. So you have some heavy hitting authors in this article. But you can go to the bottom, and they typically have to disclose any professional interests or conflicts of interest. So here they have a competing interest statement, and they go on. You can see it's actually quite lengthy, where they're discussing anyone or any foundation or corporation who may be funding some of the research. And that can be really important, particularly in the arena, for example, of a motor vehicle collision involving a concussion. You're going to find a lot of research that says, anyone with a concussion, even though it's 2020, they're still making this up. And, it's all a psychological problem. They had psychological tendencies as to why now they're going to be malingering. And you have this whole other plume of data, so to speak, showing no, there are actually things that are wrong with these individuals, and they're not confabulating these problems. So anyways, when you're trying to research like a professional, and these are the things that you may want to look at in the context of what you're trying to figure out. What does it mean when someone says there is no science? This is being thrown around a lot right now in 2020. There's no science to support this, or there's no science to support that, or there is science to support this. Well, keep in mind, for example, like with a pharmaceutical, to get a pharmaceutical to the market, it can take a company 10 years. There's an incredible amount of testing and clinical trials that one therapy is going to go through before our major organizations and our government are going to deem that it is safe for human use, and they know what the side effects are and that it is effective. So that can be the framework from which someone is saying there is no science. The reality, though, is that healthcare is not always that simple. And we have multimodal, meaning lots of times you have to approach a problem from many different angles to help someone. And that becomes really hard to study from a randomized clinical trial perspective. A randomized clinical trial is very simplistic in the realm of, if I take this pill, for example, let's say this is the active ingredient versus this as the placebo, the participant in the study really should not know any difference. And so they don't know if they're taking the placebo. They don't know if they're taking the active ingredients. And because of that, that's what creates objectivity and lack of bias. But there's a dilemma when, let's say, you have low back pain and you're trying to study the effects of low back pain with physiotherapy and chiropractic adjustments and stretching and laser, to put all those together to say, well, this person's treatment method is more valid than another type of treatment method gets fairly complicated within kind of a systems perspective. So keep in mind when someone says there's no science, it doesn't mean that there's no science. Lots of times there's a copious amount of science on a topic, and it may just be their determination that there's no science. Or it just may mean that we're in the early stages of this. This is a complicated issue with a multifactorial treatment that is not always easy to study, like a one pill treatment, whether it's a pharmaceutical or a supplement or whatever. If it's just a monotherapy, so to speak, then it's easier to study. And then I brought this article in to highlight it. This is looking at white matter microstructure in athletes with a history of concussion, comparing diffusion tensor imaging, the white matter tracking brain MRI, and neurite orientation dispersion and density imaging. And here is a good example of, they were studying varsity athletes. Some had had concussions and some had not. And they found some pretty cool stuff. But keep in mind, when other scientists are going to look at this, they're going to say, well, they did not compare it to, for example, individuals who are not athletes, because one problem, like within concussion, is that even if you're not having concussions and you're playing something like football, you're still getting subconcussive repetitive head impacts, which may skew the data. So when we start with a problem like head injuries, mild traumatic brain injuries, and how do we objectively determine if someone has actually had a problem here? Lots of times they have to not create the most perfect trial ever. They just have to dig in and start studying. Okay, what are we seeing in athletes who've had concussions, those who have not? Then they have to control for maybe gender, maybe they have to control for the type of sport, maybe they have to control for how much they were sleeping, their nutrition. There are all these different factors that then come into play and questions that scientists are going to come up with. Okay, so, and hello to everyone who's joining. So let me see here. And then, I also attached this article where it was an interesting topic looking at mice. Changes in the gut microbiota by chronic stress impair the efficacy of fluoxetine, that's Prozac. So here they're looking at how stress is impacting the gut microbiome and how that can impact how something like Prozac is going to work. And a lot of people, when you're reading on Google, may cite the study and say, well, stress impacts your gut microbiome and that can affect your antidepressant. Well, this is what they found in mice. Just because we see it in a mice doesn't mean it translates to human. And hopefully those of you who watch my broadcast regularly see that I may cite a mouse study. I'm citing it because it may be a complicated topic that we can't translate to a human. For example, the leaky gut studies I showed relative to brain injury. How do I describe this eloquently? Basically, they're inducing a brain injury. Then these mice are harvested, and then they can see the effects in the gut, and they can see the effects in the brain after a period of time. That's not feasible in humans to open someone's brain up and look at different areas without causing serious harm. So mice afford a certain glimpse as to what's going on, but again, it doesn't always translate into human beings. So those are some basics on how I research as a professional. And if you have other questions or other comments, I appreciate that. And we have one comment. Can't I just make my doctor do it? What do I pay him for? And exactly. And that is my job, and that's why I do it. And I bring you, all of you, hopefully good information. But here are just a few tips for those of you who are inquiring. So have a lovely Monday evening, everyone, and I'll probably be back tomorrow. Okay, bye.